Next up is 21. Use all available methods to factor the following polynomial equation completely. Make use of given 0. So they have this big long 0 here, this big long equation. Function, I suppose you should call it. I left enough room on my paper. This thing's huge. And we want to use all available methods to factor the polynomial. I want to factor this, so it should look like it's going to be x plus or minus something, x plus or minus something, x plus or minus something, x plus or minus something. I know there's 4 of them because the degree of this thing is 4. Now it does tell me this, negative 6i is a 0. Well, that means that you say plus 6i. Remember how you can take the factors and take the zeros and turn them into factors if you change the sign. For instance, if it told me that 3 was a 0, then I would say minus 3 up here. If it told me negative 15 was a 0, I'd say plus 15 right here. But the neat thing about this is you have an I, and if you have an I, you've taken a square root somewhere, which means it's always plus and minus. So in a sense, if they tell you that negative 6i is a 0, they're already telling you that 6i is a 0 as well, the positive and negative. So since I'm saying that I have a positive 6i, I'm going to go negative 6i here. Now, what we want to try to do now is find these other two intercepts. You get 2 options here. We can multiply this out. We'd have x squared, the 6i's would cancel, and then you'd have a negative 36i squared, which makes it x squared minus plus 36. If I multiply that together, you get this. So option 1, you take your factor, you divide it into this big long dude here, and get your answer, and then you factor that answer and you get your 2 numbers. I guess we could try to do that. X to the 4th plus 7x cubed, 46x squared plus 252x plus 360. So x squared into x to the 4th, we need another x squared. So that would be x to the 4th plus 36x squared. And if I subtract that now, so that would be 7x cubed minus plus 10x squared. I'll go ahead and bring this guy here down. 252x. So turn 7x cubed into from x squared into 7x cubed. You would need a positive 7x. Let's see, 7 times would be 210 plus 42. Oh, it's 252. That's cool. So those would cancel when you subtracted them. You'd have 10x squared plus 360. Bring down the 360 down. That cancels. So now, how do you turn x squared into 10x squared with a positive 10? And that would give you 10x squared plus 360 with a remainder of 0. Well, looky here. So this goes into here and gives you this output. Basically what I'm doing is I'm taking the factors out is what I'm doing. So what I'm left with is this part, which represents this part. I've already factored out, I divided this part out of the whole thing. I've divided it out. Now you're only left with this. And this, hopefully, will give you this. So will this factor? You put your x and an x. Positive means and this is positive, so they're both positives. And 5 times 2 gives me 7. So it factors. So x plus 5, x plus 2. Option 2 would just be to, now, hopefully you do this part first, and then get to your calculator, and graph this, and find out that it hits at 5 and 2. So you could find these other 2 numbers. Or actually, you'd find it hit at negative 5 and at negative 2, and you'd flip them. So here's showing your work algebraically, which you need to do. If you went to the graphing calculator and found these 2 numbers, you could use synthetic division to prove that those are the factors algebraically. Because you could figure out that 5 and 2, well, that's a factor of 36 divided by 1, 360 divided by 1. So You could use synthetic division to do this question as well, along with your calculator, but you always want to try to do it 2 different ways so you can make sure you get the right answer. Oh, this is the answer, by the way. This is factored form.